In this video, we're going to talk about counting our sig figs. So if I say that a standard index card is 12.65 centimeters long, approximately, the last digit here is estimated. We say that it's estimated since the smallest space on the ruler that was used was 0.1 centimeters. And I could use a metric conversion and change this number into this number. Okay. The 5, that last number right here, is still the estimated digit. So just because we added these zeros, that 5 is still estimated. The zeros are being used as what we call placeholders. Placeholding zeros are not significant. All non-zero numbers are significant. Non-zero numbers are 1 through 9. Okay. Placeholding zeros, leading zeros between the decimal and the first non-zero number, and trailing zeros without a decimal, that's going to be important, are not significant. Trapped zeros and trailing zeros with a decimal are significant. So trailing zeros without a decimal are not significant. Trailing zeros with a decimal are significant. So let's talk about the numbers down here. So these are those leading zeros. Okay. Leading zeros between the decimal and the first non-zero number. So these are not significant. However, once I get to this non-zero number, everything after it is significant because I have a decimal place. So those are significant. Now this is a non-zero number, so we know that it's significant. And since there's a decimal place here, that means that these are not placeholding zeros, they are significant digits. So these are also significant. Now here there's no decimal place. So we know without those decimal place, without a decimal, that these are placeholding zeros. So those are not significant. But 1 is a non-zero number, so it is significant. So if I were counting the sig figs here, I would say that this first one had 3 sig figs. This one had 1, 2, 3, 4, 5 sig figs. And this one had 1 sig fig. Okay. We're going to look at another method to kind of think about that. So I have a picture of the U.S. here, and I like to use what's called the Pacific Atlantic rule. So if I'm looking at the United States, the Pacific is on our left side. So the Pacific rule says that a decimal is present Pacific present. So we're going to start on the left side. Now the other option here is the Atlantic, and I'll do that one in a different color. So the Atlantic is if a decimal is absent. Atlantic, absent. So we start on the right side. So let's take a look at what that means here with some of our examples. So our first one, number 1, there's no decimal place. So we know that we're going to be looking with our Atlantic because the decimal is absent. So I'm going to start on the right side until I come to my first non-zero number. So 8 is a non-zero number, so it's significant. Once I say yes, everything else in that direction is significant. So both of those are significant, and we have 2 significant figures. So let's check out number 2 here. There's a decimal present, so I'm going to use the rule for Pacific, which tells me I'm going to start on my left side. So I'm on my left side. I'm going to wait till I come to my first non-zero number. 3 is a non-zero number, so it's significant. Once I say yes that something is a non-zero number, everything else in that direction is significant. So we have 4 sig figs there. Now looking at number 3, we have a decimal, so a decimal is present. So we're going to use our Pacific rule again. Remember, I have to come to my first non-zero number. A non-zero number is something that's 1 through 9. So 0 is not a non-zero number, so that one is not significant. 3 is a non-zero number, and remember, once I say yes, then the rest of them are significant. So we have 3 sig figs there. Let's check out number 4 here. We do have a decimal, so the decimal is present. So once again, I'm going to use that Pacific rule, starting on the left side until I come to my first non-zero number. Well, 8's a non-zero number, so it's significant. Once I say yes that something's a non-zero number, then I'm going to say everything else in that direction is significant. So we got 1, 2, 3, 4, 5, 6 significant digits there. Let's check out number 5. No decimal there, so it's absent. So we're going to follow our Atlantic rule. And I'm going to start on my left side. And I have to go until I find my first non-zero number. So is that a non-zero number? No. Is that a non-zero number? No. Is this a non-zero number? Yes. Once I say yes, everything else in that direction is significant. So I have 2 sig figs here. Now, number 6 has a decimal that is present. This is something that you can do, but I hate for you to do because sometimes this decimal gets lost. But since there is a decimal present, we're going to follow our Pacific rule, meaning I'm going to start on my left side until I come to my first non-zero number. So 4 is a non-zero number, so I'm going to say yes, it's significant. Once I say yes, everything else in that direction is significant. So I have 3 sig figs for that one. Let's check out number 7. There is not a decimal, so it's absent. I'm going to use my Atlantic rule. 0 is not significant here because I have not hit a non-zero number yet. 1 is significant, so I have 1 sig fig. Now, with scientific notation, anything in front of that 10 is significant. You can still follow the rule of Pacific Atlantic and say, yes, a decimal is present. Go to your first non-zero number. 1, 2, 3. 1, 2, 3. The times 10 matters as far as the number itself, but it does not play into significant figures. This is part of why scientific notation is used in science, and we're going to talk a little bit more about that in another video. Okay, number 10, we do have a decimal present, so I'm going to start on my left side, present Pacific. Come to my first non-zero number, 1, 2, 3, 4. 4 sig figs there. Number 11, again, my decimal is present, so I'm going to start on my left side. 0, 0, 0. I hit 4. That is a non-zero number. So 1, 2, 3. And last example on here is number 12. There's no decimal, so it's absent. We're going to follow our Atlantic rule and start on the right. So 0, 0, 0. 2 is my first non-zero number. Everything else in that direction, so again, I'm moving my hand from right to left, is significant. So we have 2 sig figs.